Hello, today we're doing word problems that go along with our quadratic functions. We are going to need to find the vertex in order to solve these problems. So we want to make a quadratic equation and we want to go ahead and find the vertex. Okay, so let's get started. I want you to think of this problem as our y is going to be our maximum weekly revenue and our x is going to be our price reductions or increases, depending on the problem. Okay? When we do these problems, we're going to set it up so that we have our y equals our price times our items. So I want you to be thinking about this. Okay, a go-kart track has about 380 racers per week, so we're going to put 380 here. Charges $35 to race, so we're going to put our price there. The owner estimates that there will be 20 more racers per week for every $1 reduction in price. So I'm going to find out how many $1 reductions we're taking. X, we don't know. We don't know how many, I should write number of price reductions or increases. We don't know how many price reductions are we taking. Are we taking 5? Are we taking 1? We don't know how many we're taking. But we think for every $1 decrease, we're going to increase by 20 racers per $1, okay, per price reduction. This is going to, when we multiply these two together, this is going to give us our quadratic function. So let's go ahead and do that. I'm just going to FOIL this out. After I FOIL it out, I'm going to combine my like terms. So that's what you're going to see me do. So I get y equals 13,300 plus 700x minus 380x minus 20x squared. Now it's a quadratic function, so I'm going to write it in descending order, and I'm going to go ahead and combine my x terms. So negative 20x squared plus 320x plus 13,300. Okay. Now, in order to solve this, what we were doing is we were finding the vertex. So we want to find the vertex because basically what we have is an upside-down parabola. We want to know what it's going to take to maximize our weekly revenue. So I'm going to find the vertex here. I'm going to do negative b over 2a. That's going to give us our x. Okay, so I'm going to get negative 320 over 2 times negative 20. When I do that, I get 8. Now, basically what this is saying, okay, now it's going to depend on the question. This is what you found. You found x. We need to understand what x represents. It says, how much should the owner of the go-kart track reduce the price by? So if I plug in 8, I'm going to plug it into just here. This is going to be how much I'm reducing the price by. So we're reducing it by 1 times 8, which is $8. We're going to take an $8 price reduction. Now be careful because sometimes the question will say, how much should the owner charge? If it's how much should the owner charge, we're going to plug it into this whole parenthesis. It doesn't say that here, it just wants to know what are we reducing the price by. And then it says in order to maximize weekly revenue. Now this question I didn't ask you for weekly revenue, but if I did, you would need to plug 8 back into our x's and you would need to solve for y. If I did that, just so you know, we would get a weekly revenue of 14,580. Okay, this is our price reduction we're taking. It's going to make our weekly revenue to be $14,580. Now we're going to go ahead and try another problem. I want you to see how it's very, very similar. Okay, here we go. We're going to have our price and we are going to have our items. Price and items, that's what this messy writing says. An online music store sells about 4,000 songs per day when it charges $1 per song. For each 5-cent increase, this time I'm increasing it. We don't know how many 5-cent increases we're going to take, so we're going to multiply our 5 cent by x. Could be 10, could be 5, could be 1. But we think for every 5-cent increase we make, we're going to sell 80 fewer songs, 80 fewer per increase. So I need those x's in there. Now I'm going to go ahead and FOIL this out. I'm going to FOIL it out. I'm going to add up like terms and I'm going to write it in descending order. I'm just going to go ahead and do that all in this step. So we get y equals negative 4x squared plus 120x plus 4,000. Now, here is my quadratic equation. It says find the total price increase that maximizes total revenue. Same kind of question we just had above. So I'm going to go ahead and do our negative b over 2a. When I do that, I get negative 120 over 2 times negative 4. I'm going to get 15. Now 15 needs to go in for x. The answer is not 15. It says find the total price increase. So I want to know how much are we increasing the price by. So if we take 15 and we multiply it by 0.05, we are increasing the price by 75 cents. This is our answer. It's a 75-cent increase. Now if I asked how much are we now charging per song, then we're going to go ahead and do the whole parenthesis, but I didn't. Now we can go ahead and also plug in our 15 into our quadratic equation and find out what our weekly revenue is going to be. And when you do that, you get $4,900. All right, let's take a look at the U-try. All I want you to do in this is set up an equation. I just would like you to get your two parentheses, and I would like you to FOIL it out so that you get your quadratic equation, ax squared plus bx plus c. So fill in these two parentheses, FOIL it out, add up your like terms, write it in descending order, and then we'll finish solving the rest of the problem in class. Moving on, the next page is a little bit easier. Here we're going to be talking about finding usually maximum height, or finding how far we're throwing a ball, kicking a ball, jumping, something of that sort. All right, it says the path of a place-kicked football can be modeled by this function, where x is the horizontal distance in yards and y is the corresponding height in yards. How far is the football kicked? What's the football's maximum height? So we're finding our x and our y. We're going to start by finding our vertex, and we're going to talk about what it means. Now, right now, if we take a look at this equation, it is not in quadratic, or it's not in vertex form, and it is not in standard form. So I'm going to go ahead, multiply this out, and get it in standard form. When I do that, I end up with y equals negative 0.026x squared plus 1.196x. This is the standard form as we can get. We're going to go ahead and find the vertex by doing negative b over 2a. When I do that, I get 23. I'm going to plug it in, and I'm going to find my y. So my vertex is 23, 13.8. Okay, now let's talk about what that means. Vertex would be this point. This would be 23, 13.8. Now let's answer the questions. How far is the football kicked? Is the football only kicked to this point? No. The football is kicked all the way here. So we take the football, we kick it horizontally this far. So what do we need to do to our x to get how far it's kicked? We need to double it. So we're going to go ahead and multiply 23 by 2. So we get 46 yards. That is how far it is kicked. Now what's the maximum height? The maximum height is our 13.8. We don't need to do anything to that because that's as high as it's going to go. That's our vertex. So this answer would be 13.8 yards. Okay, let's go ahead and try another problem just like this. All right, the function is given, or this function models the jump of a red kangaroo where x is the horizontal distance in feet and y is the corresponding height in feet. What's the kangaroo's maximum height? How long is the kangaroo's jump? So again, I want this total distance here, and I want how high it goes. Now this is an easy problem. Look what form this equation's in. It's in vertex form. So if I pull out the vertex, I get positive 14 and positive 6. So what's the kangaroo's maximum height? 6 feet. That's our y value. How long is a kangaroo's jump? Well, from here to here is 14. So what do I need to do to get how long the jump is? You need to double it. So the answer is 28 feet. Look how easy that problem is, all because it was in vertex form. All right, let's go ahead and look at the U-try. A baseball player has hit a ball. The height y of the ball, x seconds after it is hit, is given by this function. What's the maximum height of the ball? Now look, this is in standard form. We're going to go ahead and find vertex. Once we get our x value, we need to plug it back into this x and find our y, because our y is always our maximum height. Go ahead, try this problem on your own. If you have any questions, comments, or concerns, write it at the bottom of the paper, and I will see you tomorrow in class.